Hi, I hope you're having a good day. Well, we're going to have a look at a few questions on the sine and cosine and see if we can do some of these questions here that you've been studying. Right, so what we want to do here is we want to find an equation that represents a wave. So a student has got a rope and it's at a fixed point 3 feet above the ground, and the student moves this up and down, and so the rope causes a wave and it goes up and down like that. Okay, so that's the idea. And here's your formula: y equals a sine of bx plus c. And it ranges between 1 and 5 feet. Now those are important. Those are the maximum, minimum, and the sine wave is 4 pi. So there's the question. We see the rope goes up and down. The highest value is 5, the lowest value is 1. So the amplitude, the distance up and down, we go highest minus lowest divided by 2. So 5 minus 1 divided by 2, that's 4, divided by 2 is 2. So the first part of this A bit here is going to be 2. Then we'll have a look at the next bit. The 5 plus 1, this is for the D, this is the height. Well, we can obviously see it's 3 feet above, so it's going to be 3, but let's work it out. We did 5 minus 1 for the amplitude, now we do 5 plus 1 for the D value. 5 plus 1 is 6, 6 divided by 2 is 3, and that gives you our D value. So we can then write our equation as y equals 2 sine of something plus 3. Now this bit here, the 4 pi, is the period, and we're told in the graph that at the period is 4 pi. So this was an easy one to work out. Y equals 4 pi. There was no sideways shift, so I've put 0 in there. So we can write the formula then as following. So here I've pulled up a Desmos screen. There's my equation. Let's see a little bit more of the graph. So that's what it looks like when you first get it. I'm going to shift the graph over. Now there are lots of waves there. So what we can do is we can go to tools. So when I go to tools, and I'll have to move the whole screen over here, we can change our x-axis to go, let's say, from -1, and instead of going up to 24, let's make it go up to, say, 5. See what that looks like. And here we go. There's a better sine graph for us. Pull it back there, and you can see that that's now looking more like the range where we want it. So here's another question. This is determining a model for tides. So the height of a tide in a small beach town is measured along a sea wall. The water levels oscillate. That means it goes up and down between 7 feet at low tide and 15 feet at high tide. And on a particular day, the low tide occurred at 6 a.m. High tide occurred at noon. About every 12 hours the cycle repeats, so that would be a period of 12. So here's our formula: y equals, say, a sine bx plus c plus d. We want to work out a, the amplitude, so this is where we take the high and the low and we subtract them, 15 minus 7, and we divide that by 2. That gives us a value of 4. To find the d value, we add those two values and divide by 2. That's 22 divided by 2 is 11. So now we can write out, and we want the period. The period is always 2 pi. We've got our 4 and our 11 done. So we're working out the b now, and that's always 2 pi divided by a complete cycle. And a complete cycle, it said, was every 12 hours. So we go 2 pi divided by 12, which gives us a value of pi over 6. So we can now write the equation as y equals 4 sine pi over 6x plus c. We're told that the low tide is at 6 hours and it's 7 feet. So we're going to go to Desmos and we're going to put those values in, and we'll see how they come out. Right, here we're on Desmos, and I've typed the equation of the graph in and nothing appears. That's because the default screen doesn't quite show the graph. So there's my equation. You can see it's there, but no graph. What we have to do is we've got to go to the tools and we've got to zoom out to find our graph. There it is. Now I've put the 0.67 because that's where our graph has to go, but it doesn't actually go through 6, 7. So I've put a slider in, and as I move my slider, it will put the graph onto the right point. So there we go. I've got my slider at 1.6. So there it is. You can see that C is 1.6, and now it goes through the right region. So now I can finish and do my graph for that. So that's pretty cool how that works out. So now I can go ahead and work out what C is. I know that that value there is now 1.6 from my graph, so I just cross it out and I put in 1.6. You can see how the graph starts at the top and goes down to the lowest point. So this would perhaps be better modeled with a cosine graph, and I've actually got the cosine graph written here, so I'll show you, and it is exactly the same. So I'm going to make it purple, and that's the same graph, and I'll move the screen over. So there you can see that the cosine graph is exactly the same, and I've put the slider at 0. So it's just 4 cosine pi over 6x plus 11. You always need to pay attention in class. Watch what happens when you don't pay attention. A little bit hard.